The sirtuins, there are 7 of them in the body, and they're protective enzymes. They control a variety of functions in the body. They stop inflammation, they stop DNA damage or fix DNA damage. They control how obese we are, and we think they even control diseases like Alzheimer's, and ultimately how healthy we are in old age. Think of them as the traffic cops. They respond to an emergency or a perceived adversity, emergency, and they send out the troops. In relation to the epigenome, they're major regulators of those structures that I talked about. And they slow down the scratches on the CD if you keep them active. And in other words, you can access your epigenetic information much longer in life, we think. And in yeast cells, we discovered that actually now 24 years ago. It's crazy to think it was that long ago, but what we discovered in yeast cells, and so a typical yeast cell will divide about 25 times. And we were curious, and I was at MIT in the lab of Professor Lenny Guarenti, and I was trying to figure out, why do yeast cells not live forever? I mean, it's a pretty simple cell. Why can't it just keep dividing and dividing? And so what I figured out was that they have breaks in their chromosomes. They have genetic instability. And that fit with everything we knew about DNA damage being involved in aging. But what was particularly interesting was that these sirtuin proteins, these enzymes that were stabilizing the epigenome and making sure cells retain their identity throughout life, they were being distracted by this DNA damage, and they were leaving their posts to go help repair the damage because they have this dual role in the cell. And then they would have to find their way back to where they came from. And they didn't always do that. And the more DNA damage that accumulated, the more distracted they got, and the more the cell lost its identity. Eventually, those cells became sterile. And because they didn't know what sex they were, they weren't sure if they were male or female. And I wrote in my book that this is an ancient survival mechanism to stop the cells dividing when there's a broken chromosome. And so one of the questions I get from young scientists typically is, well, why doesn't the cell just give another protein that role? Why do sirtuins have to play that dual role? Isn't that ultimately going to cause aging? And the answer is, well, first of all, we only live as long as we need to, so evolution is not likely going to make us live forever. But it's a perfect way when you're young to be able to coordinate the cell cycle and the arrest of that when there's trouble, and the repair of DNA. So we call this antagonistic pleiotropy. It's just a complex way of saying things that are healthy for you when you're young come back to bite you when you're old. Evolution doesn't care. Natural selection doesn't care. Once you've reproduced, then we're all good. And typically, our ancestors got by having children in their teens and 20s. And by the time they were 40, their bodies were basically expendable. And most people didn't make it beyond that anyway due to famine, diseases, and war.